Okay, with these videos, let's continue with the process. Early morning hustle. If you're watching this, hopefully you're watching this in a contiguous manner. But here, what we're going to do is finish chi-square test, and hopefully this will be a 10-minute video. Alright, so here, again, we're doing two different chi-square tests. The colloquial way of saying a statistical question is the ratio of species in the penguin data frame consistent with each species consistent with each species. Is the ratio of species in the penguin's data frame equally distributed? Call it that. That's better. Wow, yikes. And then the statistical way of saying the same exact thing is the proportion, population proportion of each species in penguin data equally likely to occur. So in terms of species, if you remember from the last video, how many species are there? 3. So there are 3 species, okay? And so with that being said, how do I say this? Is each species ratio or proportion 1/3 essentially? Because there's only 3 different levels. And I'm gonna note this now, just so I can hold that. I'm gonna emphasize is that you don't necessarily always have to. It doesn't always have to be equally likely. You can have a specified distribution as well, like 1/2, 1/4, 1/4, for example. Okay, and so the purpose of chi-square fit is just to test if what you observe matches what you expect or your set distribution. And so what I'm going to do is I'm just going to select this variable. I guess I'm just depending on what I'm doing, I'm going to select this one. Why did I do that? Who knows? Oh, okay, I kind of understand why I did that. So then, in terms of specifying this, I'm going to save this table, save the information as a table, and I'm going to show it to you. So it's just the frequency of each of the species, and then I'm going to visualize this. And of course, I made it look nice. I try my best to make it look nice. Okay, with the frequencies on the top. Okay, that's with the geom text. Where is it? Where's geom text? Oh, I'm using stat counts. Then using geom text to then specify the counts. And then I'm making sure that it is right in the middle. Okay? Alright, so that's the visualization. In terms of the analyses, I made my non-alternative. The null is correct. So all the proportions are equal to, the population proportions are equal to 1/3, equally distributed. But then the alternative, at least one population proportion is different. That's it. Alright. So the old code, this is actually quite, I would say, straightforward. Because, yeah, it's just chi-square test, and then that table that I denoted. Okay. But again, like I said in the last video, this is a particular object. It's not a data frame. We're going to reject that, of course, because look at the 68 for goodness sakes. Okay, so we already automatically know we're going to reject the null hypothesis here. Okay, but let's use the infer package to construct the same analysis. Okay, so we're going to do, if I can think. This is stat number 4. Yeah, stat number 4. Is it really stat number 4? I should just use penguins. It's stat number 4. Okay, good. And then I'm just going to type this into chi test. Okay. And I'm going to specify the response variable like we did for one population proportion. And it's going to be species. I have to put in quotes. And species. Since I'm looking at all three levels at the same time, I don't have to specify my success rate. Okay, I don't have to do that. But I have to delineate or specify my expected proportions. So if it's equally likely, store it as a vector 1/3, comma 1/3, comma 1/3. Okay? And so again, if I wanted it to be if I expect the distribution to be 0.5, 0.25, 0.25, they all go to 1, I can do that here as well. So here we go. All right, that statistic is 31, 31. Degrees of freedom is 2, k minus 1, p-value, so on. Save as the table. And I really like this typical data framework of thought because you can do multiple tests, right? And then just stick row bind, just do a bunch of tests and stick them on top of one another, okay? And so that's the power behind using these chi-square tests, whereas this is quite clunky to get information out of. All right, so chi-square, I feel as though I'm wanting to get to 10 minutes. All right, let's go. So chi-square test of independence, what we're going to see is there a relationship between species and the sex of the penguin? And then here, in terms of statistical terminology, is there a significant association, between the species and sex of the penguins? And so, what we're trying to do with chi-square tests of independence is to see if two variables are associated with one another. To see if two variables are associated with one another. And so, I'm going to not only select these two variables. As you can imagine, you can do these statistical techniques without saving them. Just only specifying the two variables. But I want to specifically just look at these two variables within the table. So when I do, and I'm going to save this because I'm using that for the analysis. So when I save this, I can see a contingency table of species versus sex. Okay. And then I create this nifty bar plot. And I don't think I need to use the drop NAs, but that's fine. They look quite similar to me across each species, indicating that these two variables are independent regardless of the species. I'm going to get the same number of sex, okay? Well, let's statistically state that. And so here, in terms of the null hypothesis, I don't know why I did that. The null hypothesis is that they're independent, okay? And the alternative is that they are dependent, okay? So how do I do this? This is actually, again, straightforward here in terms of syntax. Chi-square test of species, sex tab, if I can spell, okay? Look at that p-value. You're going to fail to reject that. And then finally, so that in the degrees of freedom is 2, test statistic is 0.048. Let's do it using infer. This is stat 5. Stat 5 is good. Gotta find my packet. So here, you gotta do a little bit more work. I'm just gonna type it into the chi-square. Test, okay, and then the formula. This may not work. I'm looking for a particular error. We'll see what happens. Sex is to the species, and I'm going to argue that if I were to switch to order, it doesn't matter. But this is saying the species predict sex. I honestly think that you get the same result regardless. So this is the same test statistic as before. Degrees of freedom as well as p-value. They're doing the same thing. Again, the hidden benefit is that you can stack these. You have a huge data frame. We're working with 344 rows. You can imagine you have different penguin data sets across, the Antarctic, I don't know. And you want to do this analysis across each of those different locations. You can do this analysis, but then bind them in one table. But my argument here is that I'm going to get the same results regardless. Species and sex. It should give me the same results. Okay, and that's more so the situation. The explanatory variable would be I don't know. Yeah, this is a hard one. The explanatory variable will be sex. Okay, so I'm still working on the one-way ANOVA. Thank you all for watching, and we're gonna not hit 10 minutes unless I just keep talking and rambling, and I'm not going to do that. Thank you for watching again. Good job.